Here are the notes for Unit 8 and 3 Conduction. So conduction just occurs when two objects that have different net charges come into contact with one another. Because of this contact, the negative charges will always move from an area with more negative charge, so high negative density, to a low negative density. So if you look at our example here we have a very negative object because it has way more negative charges than positive charges. And here we have an object that's just positive, it has no negatives on it. So when these two objects touch, it is going to transfer some of its negatives over to the other object. And that process, when you transfer electrons from one object to another object through touching, that is called conduction. So the rules of conduction are as follows. Positive charges do not move. So same as yesterday, positive charges will never move. It will be the negative charges that move, and they will go from an area where there are a lot of negative charges, the higher negatively charged object, to an area with low negative charge density, so just less negative charges or fewer negative charges. Negative charges will stop moving when two objects contain the same ratio of positive to negative charges, or another way to say it, when they have the same net charge, and we'll see examples of this in a second. So here's our example. Before, we have this object on the left and this object on the right. If we take a look, this one is neutral, 4 positives, 4 negatives. This one is negatively charged, a net negative charge, because it has 1, 2, 3, 4 positives and 8 negatives. So in this case, when they touch, these electrons, some of them are going to hop over to this one because here we have a negative object and here we have a neutral object. So the negatives are going to go from an area of high negative density to an area of lower negative density. So when they touch, positives stay in the same spot. And we are going to look at the charges to determine how many of the negative charges actually jump over. So this one, again, is neutral. This one has a net charge of -4. Remember, this works like ions from first semester. I have 8 negatives and 4 positives. That's why I have a net charge of -4, because I have 4 extra negative charges on this thing. So if we look, they are going to exchange electrons or negative charges until they have the same net charge. So what that means is if I transfer 2 negatives over, they'll both be at -2. So there, if we look at it, I have 6 electrons on this one, 6 electrons on this one, same net charge. So that is our conduction process. If we transferred, like let's say we transferred a third electron over here, then this would be -3 and this would be -1, and then that electron would just hop back. So what happens here is we transfer electrons until they have the same net charge, and then since they're balanced, they have the same net charge, they're not going to transfer any more electrons. Here's another example. This time we have 3 positives over here and 1 negative, so this object has a net charge of +2, whereas this object is neutral. At the end, remember, positive charges don't move, so we'll just put them back in the same spot. When we look at this one, +2, neutral, so that means we are going to transfer 1 electron over, and then both objects will be +1, or +1 for their charge. Again, same net charge, so we can do this, just basically find the average of the 2 net charges to get the final charge. This time we can do it just in a word problem. So object A starts with a charge of -8. B starts with a charge of +2. What will their net charges be after they touch? Here we just look at our charges again. So we have -8 and +2. That's a total of -6. And then we just divide that by 2 to get the average net charge here. So they're both going to end with a charge of -3. So both have a net charge at the end of -3. Lastly, here is an object that is negatively charged. So if we look, we have 1, 2, 3 positives and 6 negatives. This object is going to, if you look down at the bottom, it's going to come in contact with the ground. So we're just drawing what grounding looks like. So in this process, it comes into contact with the ground. Positives stay in the same place as they always do. It becomes neutral when it is grounded. So that means it loses 3 of its electrons and just leaves 3 on there. So anytime you touch an object to the ground, remember from the previous notes that it is going to go back to neutral. So if it has extra negatives like this one, it loses them into the ground. If it went in the other direction, like let's say it was positive, it would take some electrons out of the ground, but it always just goes back to neutral once it is grounded.